Module 13, the digestive system. The mouth, pharynx, and esophagus. Well, it's time to look at the digestive process one section at a time. When we eat, we begin digesting our food immediately. That's because digestion begins at the mouth. When you take a bite of food, you chew it, right? So your teeth are a very important part of digestion. Look at this image of teeth. They're made of bony material embedded in softer gums that behave like shock absorbers. You can see that there are different tooth shapes too. The incisors are sharp and work together the same way that scissors do to cut off pieces of food. The canine teeth are sharp and pointy for tearing food. If you're trying to bite into a tough piece of food such as hard, crusty bread, you will likely use the canines for that tearing job. And finally, you have premolars and molars to act as crushing mechanisms to grind up the food. As the teeth do their job of cutting and grinding the food, the salivary glands release saliva into the mouth to help moisten everything. Saliva is made up of mostly water, along with a few important chemicals. The addition of saliva helps to dissolve food. That helps your taste buds then to identify specific tastes, as the dissolved food enters the taste pores of the taste buds. Saliva also contains mucus, which provides lubrication to make the food more slippery as it moves through the digestive tract. Amylase is a digestive enzyme in saliva to help break down starches into maltose. Maltose is a disaccharide made up of two glucose molecules. If you were to take a plain cracker and place it in your mouth without chewing it, you'd notice that it would begin to break down. If you allowed more saliva to enter your mouth, you also might notice that the cracker would begin to taste a bit sweet. That's because the amylase of the saliva is beginning to break down the starchy carbohydrate material into maltose sugar. Another component in saliva is lysozyme. Its job is to kill bacteria. Your mouth can quickly fill with saliva if needed, and that's thanks to the three major pairs of salivary glands located throughout the mouth. The parotid glands are the largest pair of glands. You have one on each side of your throat, and they release saliva above the tongue near the second molar of the upper jaw. The second molar is the one just before your wisdom teeth if you have them. You can even feel the opening of the duct, which feels like a small bump just inside those upper molars. If a person gets an infection called the mumps, they will have a swelling in the cheek area. The mumps is due to a viral infection of the parotid glands. The other two pairs of major salivary glands are the sublingual and submandibular salivary glands. They release saliva under the tongue. If you close your mouth and create a suction just under your tongue, you may be able to cause those glands to release saliva there. Sublingual refers to under the tongue, and submandibular refers to in the mandible or lower jaw. Now, there are also many smaller salivary glands in the tongue, cheeks, and even on the lips. They all work hard to keep your mouth moistened, provide moisture for the food you eat, and kill potential foreign invaders. You secrete about 1 liter of saliva every day, and this secretion is controlled by the autonomic nervous system. In fact, the senses of taste and smell send signals to the medulla oblongata in the brain, which then causes the autonomic nervous system to make the salivary glands work. You may notice this when you enter your home while a meatloaf is being cooked in the oven. That amazing aroma sends olfactory signals to your medulla oblongata, which then stimulates the salivary glands to secrete saliva. And you salivate, getting ready to have a great meal. The actual motion of chewing also stimulates saliva to be released. If you chew gum, even once it's lost its flavor, the autonomic system of your body will continue to signal the secretion of saliva in response to that chewing, even though there's nothing to digest. Now, as the food has been chewed and saliva has been mixed in, the tongue moves the food around until it forms a ball-shaped lump called a bolus. Now you are ready for deglutition. Deglutition is the act of swallowing, and it can be a risky act. This is because the cavity of the mouth opens up to the pharynx, but the pharynx opens up to the esophagus and the larynx. When you breathe, air enters the larynx, then the trachea, and then the lungs. So food has to pass by the larynx in order to get to the esophagus, and it has to do it in such a way that it doesn't enter the larynx. In other words, so it doesn't go down the wrong pipe. So when you swallow, the airway has to be closed off and protected from the bolus entering it, and your body is designed so this happens. During deglutition, the soft palate rises up and blocks off the nasal cavity. That's so food doesn't enter your nose, and thus you're not able to breathe through your nose at this point. Additionally, the epiglottis moves downward to seal off the larynx, so food can't get into the trachea. This is a pretty well-coordinated process. But have you ever laughed while drinking milk and had some milk come out your nose? That's because the soft palate moved from its proper position. You see, when you are regularly breathing through your nose, your soft palate hangs a bit downward so it completely blocks off your mouth. But when you swallow food, your soft palate moves upward to block off your nasal cavity. When you laugh while drinking, your soft palate begins to jiggle up and down, allowing some of that milk to make it into the nasal cavity, and milk comes out your nose. Sometimes the epiglottal mechanism doesn't work when you're eating. If that happens, a bit of the bolus can make it into the larynx instead of the esophagus, and you may feel like you're choking a bit. But the lining of the larynx and trachea is extremely sensitive, so if any particle that's not air enters, food, dust, or otherwise, action potentials are sent to the brain, which triggers a cough reflex. Thus, any foreign particles that are in the larynx are expelled. Though deglutition or swallowing seems like a simple, straightforward process, there are actually 3 stages to it. The first stage is called the voluntary oral stage. This stage is where you still have control over whether food goes down your esophagus or if you want to spit it out. You know that once it gets past a certain point, the food is on a one-way trip. So as long as you're still able to spit food back out of your mouth, you are in the voluntary oral stage. The bolus is moving around as a result of your tongue movement, and it gets pushed toward the back of the mouth. Once it reaches the pharynx, the second stage of deglutition occurs. It's called the pharyngeal stage. Unlike the voluntary oral stage, this stage is involuntary. In this stage, the soft palate raises up to block the nasal cavity. Thus, during this time, you're unable to breathe. Simultaneously, the larynx lifts up to meet the epiglottis, and this closes off the larynx and trachea below. Additionally, the true vocal cords, or vocal folds, move together to form a tight seal, furthering the protection of the trachea. At this point, the pharyngeal muscles contract, pushing the bolus down toward the esophagus. For all of this to happen, a highly coordinated pattern of action potentials and muscle contraction has to occur. The third and final stage of deglutition is the esophageal stage. This is also an involuntary stage. What happens is that rings of muscle surrounding the esophagus begin to contract and relax in a wave-like pattern, so the bolus is pushed down the esophagus. This coordinated process is called peristalsis. Peristalsis is the process of contraction and relaxation of circular smooth muscle that pushes food through the alimentary canal. Peristalsis is a wave-like pattern of muscle contraction known as peristaltic waves. As the bolus makes its way down the esophagus, the smooth muscle just below it relaxes. The smooth muscle just above it contracts, so the bolus is forced downward. So a wave of relaxation leads the wave of contraction behind it, and the bolus moves all the way down the esophagus. The esophagus is bordered by 2 sphincter muscles, one at the top and one at the bottom. Sphincter muscles are rings of muscle tissue. Unless a person is swallowing, these rings will stay tightly contracted so that no food enters the esophagus from either direction. As the bolus moves down into the pharynx, the upper esophageal sphincter relaxes as a result to the peristaltic wave. The bolus enters the esophagus and the peristaltic wave continues, pushing it downward. When it reaches the bottom, the lower esophageal sphincter relaxes, allowing the bolus to leave the esophagus and move on. It then quickly contracts back again. This coordinated motion is started by the presence of the bolus. It creates pressure at the pharynx, which sends a message to the pons and medulla oblongata in the brain. In fact, it takes 8 cranial nerves in order for a person to swallow, 4 on each side. Much of the upper part of the swallowing process is controlled by skeletal muscles, and then the lower half is controlled by smooth muscles. Because so many nerves are required for this coordinated effort of deglutition, any small nerve damage can affect a person's ability to swallow.